This question asks you to identify true statements about different kernels used with scikit-learns. Gaussian process regression say as interpret as characters GPR say as. Google style name lively. Let's dive in. Google style break time 300 milliseconds. Well, examine each statement's accuracy. Statement B says a say is interpret as characters. Rational quadratic say is kernel handles both smooth and not smooth functions, depending on its settings. Google style name assertive. That's correct. Google style break time 300 milliseconds. This kernel's flexibility is a key feature. It can adapt to various data complexities. Statement C states that adding kernels using a sign adds their covariance matrices together. Google style name explanatory. This is fundamental kernel arithmetic in Google style say as. Interpret as characters GPR say is Google style name explanatory. Google style break time 300 milliseconds. It's absolutely true. Statement A claims that a radial basis function say is interpret as characters RBF say is kernel always gives a smooth prediction surface. Google style NAMI emphatic id caution against that. Google style break time 300 milliseconds while generally smooth. And say is interpret as characters RBF say is kernel smoothness depends on its length scale parameter. A very small value could make the prediction less smooth. Statement D suggests that the say is interpret as characters. Product say is kernel is best for modeling primarily linear relationships. Google style name emphatic. That's partially correct. Google style break time 300 milliseconds. It is good for linear relationships. But it's also often paired with other kernels to capture both linear and nonlinear patterns in data. This whole question focuses on understanding how different kernels in scikit-learn's Gaussian process regression say is interpret as characters GPR say is behave and how they can be combined. Google style name confident. Let's tackle the problem together. Google style break time 300 milliseconds. You need to know the properties of say as. Interpret as characters RBF say as. Say is interpret as characters rational quadratic say as. And say is interpret as characters. Product say as kernels. I am focusing on the different kernels you can use with scikit-learn's Gaussian process regression GPR. This is a crucial step because the kernel dictates how your model will learn to capture relationships in your data. Choosing the right one is key to getting good predictions. Break time 300 milliseconds. I need to carefully consider the properties of each kernel type to match them correctly with the characteristics of my data. Break time 300 milliseconds. I am using the Gaussian process regression GPR tool from the popular Python library scikit-learn. Break time 300 milliseconds GPR is a powerful method for regression problems. And scikit-learn provides a user-friendly implementation. Break time 300 milliseconds. I am exploring how to choose and use the different kernels available within this function. Break time 300 milliseconds. This is the core multiple choice question focusing on the understanding of kernels within a context of scikit-learn's Gaussian process regressor. Break time 300 milliseconds. I need to carefully evaluate each statement about how different kernels behave. Break time 300 milliseconds. I'll select only those that correctly describe the characteristics of the kernels used in GPR. This is a multiple choice question. Break time 300 milliseconds. I'll choose one or more of the options provided as my answer. Break time 300 milliseconds. I am working with Gaussian process regression GPR, which is a powerful and flexible method for regression. Break time 300 milliseconds. A crucial part of GPR is selecting the right kernel. Break time 300 milliseconds. The kernel determines how the model represents the relationships between data points and influences the smoothness and flexibility of the resulting predictions. There are many kernels to choose from, and understanding their properties is important for effective modeling. Break time 300 milliseconds. I'd say that statement is say as interpret as characters false say as. While a radial basis function RBF kernel usually gives you a smooth prediction. Break time 300 milliseconds, it's not a guarantee. The smoothness depends heavily on a parameter called the length scale. Think of it like this: a small length scale means the function wiggles a lot. Break time 300 milliseconds, while a large length scale means it's smoother. Break time 300 milliseconds. So, a very small length scale will give you a prediction surface that is far from smooth. That's say as interpret as characters true say as. Break time 300 milliseconds. The rational quadratic kernel is like a supercharged version of the RBF kernel. It has an extra parameter alpha that lets you control how smooth or wiggly the function is. Break time 300 milliseconds, so it's more flexible. Break time 300 milliseconds, I think it's really powerful. This one is say as interpret as characters true say as 2. Break time 300 milliseconds. When you add kernels using the plus sign, you are essentially adding their covariance matrices. The covariance matrix tells you how related different parts of the input data are. Break time 300 milliseconds. Adding them together basically combines the relationships. I would say this statement is say as interpret as characters partially true say as. The dot product kernel is excellent for finding linear relationships in data. Break time 300 milliseconds, however. It's often used alongside other kernels to handle both linear and nonlinear patterns in your data. So saying it's Google style name lively only Google style suitable for linear relationships is a bit of an oversimplification. I disagree. While the radial basis function RBF kernel usually creates smooth predictions, it's not a guarantee. Google style name assertive. The smoothness depends heavily on a setting called the length scale. Google style. Break time 300 milliseconds. A tiny length scale can result in a bumpy, not so smooth prediction. I agree. Google style name excited. The rational quadratic kernel is super flexible. Google style break time 300 milliseconds. It can adapt to model data that's either smooth or has a lot of jaggedness. Google style name conversational, all by tweaking a parameter called alpha. Google style. Absolutely correct. When you add kernels together using the plus sign, Google style name helpful, you are essentially adding their covariance matrices. Google style. Break time 300 milliseconds. The covariance matrix describes how different data points relate to each other. Adding them combines these relationships. It's partially true. The dot product kernel is great for linear relationships. However, Google style name cautionary, it's often used with other kernels to catch both linear and nonlinear aspects of the data. Google style. Break time 300 milliseconds. Saying it only works for linear relationships is too simple. I see that you are looking at the rational quadratic kernel. It's pretty cool because it's super flexible. It can handle both smoothly changing data and data with sharp changes, all depending on how you set its parameters. Break time 300 ms. Think of it like a Swiss Army knife for your data. It's got the tools to handle various situations. Let's talk about combining kernels. Break time 300 ms. Imagine kernels as building blocks. When you add kernels using the plus sign, you are essentially adding their individual covariance matrices together. This lets you create more complex models by combining the strengths of different kernel types. It's like mixing different ingredients in a recipe to get a unique flavor. The dot product kernel is a great choice when your data shows a mainly linear relationship between features, Break time 300 ms. Think of it as a tool that excels at finding straight lines in your data. It might not be the best fit if the relationships are curvy and complex. Sometimes, however, you'll combine it with other kernels to get a more complete picture. It's like having a ruler to measure straight lines but also using a flexible tape measure for curves. While the radial basis function RBF kernel typically produces smooth results, break time 300 ms. I want to caution you, it's not a guarantee. Break time 300 ms. The smoothness depends on a parameter called the length scale. If you make the length scale very small, you can end up with a surface that isn't so smooth after all. It's not always a perfectly smooth surface like glass, it can have subtle bumps depending on that parameter. I am focusing on Gaussian process regression (GPR), a powerful machine learning technique for predicting values. A key part of GPR is choosing the right kernel, which dictates how the model learns relationships in the data. Break time 300 milliseconds. Well, look at different kernel types and how they affect the predictions. This is a multiple choice quiz. I'll present some statements about different kernels used in GPR, and you'll have to choose the correct ones. Break time 300 milliseconds. Get ready to test your knowledge. This question asks you to identify which statements correctly describe how different kernels behave. Within the scikit-learn's say as interpret as characters Gaussian process regresses a as function. Let's examine each statement carefully to figure out which are true and which are false. The radial basis function say as interpret as characters RBF say as kernel usually creates a smooth prediction, but it's not a guarantee. Break time 300 milliseconds. The smoothness depends on a parameter called the length scale. With a very small length scale, the prediction might get bumpy and not so smooth. So this statement is false. The say is interpret as characters rational quadratic say as kernel is amazing. Break time 300 milliseconds. It's flexible. By tweaking its parameters, I can make it model smooth or non-smooth data. Whatever suits the problem best. This statement is true. Combining kernels using a plus sign is like adding their individual influence on the prediction. Break time 300 milliseconds. Mathematically, it means adding their covariance matrices. This statement is definitely true. The say is interpret as characters dot product say is kernel is great for situations where the relationship between your data points is mainly linear. Break time 300 milliseconds. However, it's often used alongside other kernels to capture both linear and nonlinear patterns. Thinking it only works with linear relationships is an oversimplification. This statement is therefore false. Choosing the right kernel is a crucial part of GPR. Break time 300 milliseconds. The selection depends on the nature of your data and what kind of relationship you expect between the input features and the output values. Break time 300 milliseconds. Each kernel has unique properties, and a careful understanding of these properties is essential for building accurate and effective GPR models. This question focuses on understanding different kernels used in Gaussian process regression (GPR), a powerful machine learning technique for regression tasks. I'll guide you through the concepts. Break time 300 milliseconds. We will examine properties of several kernels in scikit-learn, a popular Python library for machine learning. Break time 300 milliseconds. Get ready to explore the world of kernels. Break time 300 milliseconds. This is a multiple choice question about Gaussian process regression, which uses kernels to define relationships between data points. Break time 300 milliseconds. I will go through each statement carefully and explain why it is true or false. Break time 300 milliseconds. Remember that GPR is a powerful model for regression tasks. And understanding kernels is key to using it effectively. Break time 300 milliseconds. The radial basis function RBF kernel generally produces smooth predictions. But this smoothness depends on a parameter called the length scale. Break time 300 milliseconds, a small length scale leads to less smooth predictions. And therefore the statement is false. Break time 300 milliseconds. Think of it like drawing a curve. A large length scale makes a smoother curve, while a small one makes a more jagged one. Break time 300 milliseconds. The rational quadratic kernel is an excellent choice. Break time 300 milliseconds. It's a generalization of the RBF kernel and can model both smooth and non-smooth functions because it has an additional parameter, often called alpha, that controls the transition between smooth and non-smooth behavior. Break time 300 milliseconds. It's true, this flexibility makes it very useful. Break time 300 milliseconds. In GPR, kernels are mathematical functions that describe how data points relate to each other. Break time 300 milliseconds. The plus operator combines these functions by adding their covariance matrices, which capture the relationships between data points. Break time 300 milliseconds. So, it's true. Adding kernels is a common way to build more complex models that capture various aspects of data. Break time 300 milliseconds. The dot product kernel is designed to model linear relationships between features in data. Break time 300 milliseconds. Although it can be used in conjunction with other kernels to improve flexibility and model both linear and nonlinear relationships, it is primarily for linear relationships. Break time 300 milliseconds. Therefore, this statement is also true. Break time 300 milliseconds. Based on the analysis above, statements B, C, and D are true. Break time 300 ms. Remember, understanding the properties of different kernels is essential for successfully applying GPR to various regression tasks. Break time 300 milliseconds. I hope you found this explanation helpful. Break time 300 milliseconds.